Okay, so now we're going to look at a case where the two events we're looking at are not mutually exclusive. There potentially could be a way to draw one card and get both outcomes. And here's a great example. Let's say that we're interested in drawing a diamond from a deck of 52 cards or drawing a picture card. So this will be my A and my B respectively. And I want to know what the probability of A or B happening. Well, again, we want to think of it as simply adding the probability of A and the probability of B, but we have to correct for the fact that there's at least a few cards that are picture cards and diamonds. So if you draw the king of diamonds, both events are true. So what you've got, essentially a Venn diagram. But they overlap. This is why they're not mutually exclusive. If we look at the number of diamonds, there's 13 diamonds. How many picture cards are there? There's 12. But there's 3 cards that are picture cards and diamonds, right? So in the middle we've got 3. Now that means if we subtract, we've got 9 cards over here and we've got 10 cards over here. Okay, so 12 represents all of the picture cards, 13 represents all of the diamond cards, but the 3 represents the overlap. By drawing this Venn diagram, we've taken that overlap and collapsed it into one thing. So we could simply add these 3 numbers and get our probability. If we simply add the 13 and the 12 like we would do normally, right? If we would simply take out and do the probability of A plus the probability of B, we would be incorrect because this adds up, 13 and 12, that adds up to 25. Whereas if you add these, it only adds up to, let's see, 19, 22, right? So we know the answer is 22 by looking at our Venn diagram, but this will not get us 22. So what we have to do is essentially remember that we counted this 3 twice. We counted it over here, and then we counted it over here, right? So the 3 is embedded in both of these. So we really just need to subtract off 1 of the value of that overlap. So we're just going to subtract the probability that both happen, A and B, okay? But just one time. We've counted them twice. We're just going to take one of them off. So in this scenario, we've got the 13 out of 52. We've got the 12 out of 52. And we just need to subtract off 3 of the 52. And you'll see that we get the correct amount, 22 out of 52. Or we can simplify that to 11 out of 26. And that is our correct probability. A and B, where we account for the fact that there's some cases where both could be true at the same time. So we just have to watch out for that. The formula is still basically the same. We're just taking and adjusting for the fact that there are a few cases where both could be true.